Oceanography News.
So water roll me home. Day will come, but night is long. The siren song still calls me young. The fading candle is growing dim. So water pull me in.
Major news has come out regarding Earth's oceans and the currents. The Southern Ocean Current reverses for the first time, signaling risk of climate system collapse. The Deep Western Boundary Current, DWBC, runs along the western boundary of the Atlantic Ocean from the subpolar North Atlantic to the South American region. In its western subpolar origins, it is composed of the densest water masses formed by deep convection in the western and eastern subpolar North Atlantic deep water, NADW. For this reason, and due to inferences from theoretical models, the DWBC was classically considered as the principal southward conduit of the NADW, of the Atlantic Meridional Overturning Circulation, AMOC. As you can see from this image, it stretches from the Labrador Sea all the way down the east coast of Brazil. As you can see here, the DWBC flows next to and under the Gulf Stream in the opposite direction, bringing cold water south as the Gulf Stream brings warm water north. As you can see here, around the Grand Banks and the east coast of the US, it is flowing just inside of the Gulf Stream. As you can see down around South America, the velocity and the magnitude of the DWBC as it continues on its journey south. A major ocean current in the southern hemisphere has reversed direction for the first time in recorded history in what climatologists are calling a catastrophic tipping point in the global climate system. The development, which was confirmed by Spanish marine scientists at El Institut de Ciencias del Mar in Barcelona, has triggered widespread alarm among climate scientists due to its potential to accelerate global warming and destabilize weather patterns worldwide. The stunning reversal of ocean circulation in the southern hemisphere confirms the global climate system has entered a catastrophic phase, said climate activist Ben C. in a post on social media. Collapse involves the deep overturning circulation in the South Atlantic, part of the global conveyor belt of ocean currents, which typically pulls cold, nutrient-rich water up from the ocean floor and drives planetary heat distribution. The study, published on July 2nd, identifies a collapse and reversal of the Deep Western Boundary Current, DWBC, in the South Atlantic, a key part of the Atlantic Meridional Overturning Circulation, AMOC. The ICM's data show that the flow of the DWBC current reversed from northward to southward for several consecutive months in 2023, the first such event in 30 years of continuous monitoring. This is an unprecedented observation and a potential game changer, said physicist and lead author Dr. Marilena Altmans, who warned the changes could alter the Southern Ocean's capacity to sequester heat and carbon. The reversal is likely an ongoing weakening of the Atlantic overturning circulation, a deep ocean process driven by the formation of cold, salty water masses near Antarctica. The system has slowed by up to 40% since the late 90s, and the new finding suggests it may be destabilizing regional ocean dynamics more rapidly than expected. There's been a lot of speculation about the AMOC coming to a halt. The AMOC brings warm water to Europe from the equator. When it stops flowing, that will lead to a mini ice age in Europe, with winter temperatures dropping by 10 to 30 degrees Celsius. While scientists are 98% certain that the AMOC will stop flowing by 2100, recent studies suggest the collapse could come as soon as this year or in the next few decades. The ICM report warns that the reversal of the DWBC could also unleash vast amounts of carbon dioxide currently trapped in deep ocean reservoirs. The reversal will undermine the ocean's role as a carbon sink, which currently absorbs about 25% of all anthropogenic CO2 emissions. This could double current atmospheric CO2 concentrations by releasing carbon that has been stored in the deep ocean for centuries, the report said. Such a release would likely obliterate existing climate targets, as the additional emissions would overwhelm current carbon budgets and render mitigation strategies based on gradual reductions obsolete. The plan is sending us increasingly clear signals that we are crossing critical thresholds, the ICM warned. Characterizing the event is a shift from chronic climate stress to acute system breakdown. The Mediterranean is hot as bathwater. The event coincides with an unprecedented marine heat wave in the Mediterranean. A Spanish meteorological buoy recorded a sea temperature of 31 C on July 4th, as hot as a lukewarm bath. The northwestern Mediterranean Sea has recorded temperature anomaly of plus 6.21 C above the 1982 to 2015 average, part of a pattern of record marine heat waves scientists say are reshaping ecosystems.
Atlantic Meridional Overturning Circulation, or AMOC, is a system of ocean currents that forms a vertical loop that spans the whole length of the Atlantic Ocean. Every second, it moves an incredible 17 million cubic meters of warm water north along the ocean surface, returning cold water south through the ocean depths.
The Atlantic's major circulation current is showing worrying signs, but is collapse near? Something stirring in the Atlantic Meridional Overturning Circulation, and a strange hole of cold water in the North Atlantic may provide new clues about what's up. But is the system on the brink of full-blown collapse, or will it keep churning on despite mounting pressure? In recent years, scientists have suggested the AMOC is weakening due to changes in the water entering the system. The prime drivers of this, shifts in rainfall and Greenland ice sheet melt, are both associated with human-driven climate change. It's becoming increasingly evident that the slowdown of the AMOC may already be starting to impact our world. New research by the University of California, Riverside has affirmed that the theory of the unusual hole of cold water in the North Atlantic near Greenland is the result of the AMOC slowing down. People have been asking why this cold spot exists. We found the most likely answer is a weakening AMOC. Wei Liu, a climate scientist who led the study with doctoral student K-Wan Lee, said in a statement. These changes aren't limited to the Northern Hemisphere either. Another study has found that the circulation slowdown of the AMOC is causing an increase in rainfall in the southern Amazon during the dry season. By analyzing data from 1982 to 2022 with advanced methods, researchers found that for every 1 million cubic meters decrease in AMOC strength, the dry season rainfall in the southern Amazon increases by about 4.8% each year. Amazon is still drying. The stabilizing interaction we found from the AMOC under the southern Amazon competes with other effects like those arising from deforestation and increasing temperatures, which would cause continued Amazon drying that interaction will not be able to compensate for long term. Nico Wunderling, the study co-author from Potsdam Institute for Climate Impact Research and Center for Critical Computational Studies in Frankfurt, said in another statement, "To accurately estimate future risks, we need to understand these complex interactions. A study adds an important piece to the puzzle," added Wunderling. Previously, some researchers have suggested that the slowing down could catastrophically collapse the AMOC entirely, marking an irreversible tipping point of Earth's natural systems. However, a third recent study suggests this is unlikely to be the case. While researchers acknowledge the AMOC is slowing down, their models of ocean circulation indicate that it's unlikely to grind to a halt entirely. In fact, the weakening over the next few decades might not be as severe as once feared. Our results imply that rather than a substantial decline, the AMOC is more likely to experience a limited decline over the 21st century, still some weakening but less drastic than previous projections suggest, Dave Bonin, study author and former graduate student at Caltech, said in his statement. Bear in mind, though, that the study is just one of many voices in the conversation. Some scientists are optimistic that the AMOC is not doomed to collapse, while others believe we should be extremely worried about its future. Either way, these findings underscore the urgency of deepening our understanding of the AMOC. As we can see here, this is the study that was referenced in regards to the AMOC's effects on the southern Amazon rainforest, establishing an interaction between the two. The conclusion from the study was, our findings suggest that without a weakening AMOC, the Amazon rainforest, AR, might be losing resilience even more rapidly, undergoing global warming and other anthropogenic pressures such as deforestation. However, despite the stabilizing interaction between the two assessed tipping elements, concurrent resilient losses have been observed for both the AMOC as well as the Amazon rainforest in recent decades. This implies that other critical drivers of Amazon rainforest stability, such as global warming and deforestation, have destabilizing effects that the interaction from the AMOC cannot fully compensate for. Thus, all possible measures to mitigate and, if possible, reverse additional global warming need to be pursued, and further deforestation of the Amazon rainforest needs to be terminated. A new article coming out June 11th, ocean current collapse could trigger profound cooling in northern Europe, even with global warming. Could the collapse of the AMOC cause the scenario we saw in the movie The Day After Tomorrow? A collapse of key Atlantic Ocean currents could cause winter temperatures to plunge across northern Europe, overriding the warming driven by human activity. That is according to new research published in the Geophysical Research Letters, which looks at the combined impact of the shutdown of the AMOC and global warming on temperatures in northern Europe. Scientists have warned that human-caused climate change is likely causing AMOC to weaken, and that continued warming could push it towards a tipping point. The study suggests that in an intermediate emission scenario, greenhouse gas-driven warming would not be able to outweigh the cooling impact of an AMOC collapse. In this modeled world, 1 in 10 winters in London could see cold extremes approaching minus 20 degrees Celsius. Winter extremes in Oslo and Norway, meanwhile, could plummet to around minus 48 degrees Celsius. Lead author Dr. René van Western, a researcher in oceanography at Utrecht University, says Europe might stand alone as the one region set to get cooler in a warmer world, he tells Carbon Brief. Quote, if AMOC collapses, we need to prepare for substantially cooler winters. Winter extremes will be very substantial for some regions. Temperatures could go down to minus 50 degrees in Scandinavia, at minus 40 degrees Celsius and lower in Scandinavia. Everything breaks down over there. The research is being published alongside an interactive map featured below, which highlights how collapsed AMOC under different warming scenarios could impact temperature averages, extremes, and sea ice across Europe. Will warming or cooling win? AMOC is a system of ocean currents which plays a crucial role in keeping Europe warm. It transports warm water northwards from the tropics to Europe and cold deep waters back southwards. Potential collapse of these ocean currents caused by the influx of fresh water from melting ice as well as rising air temperatures is seen by some scientists as a tipping point that once triggered would be irreversible on human timescales. However, there is a significant debate around whether human-caused climate change is causing the AMOC to slow down and whether when it might tip. The tipping of the AMOC is often referred to as collapse, breakdown, or shutdown. Some scientists have argued that ocean currents have been slowing down since the mid-20th century, where others say there has been no weakening since the 1960s. Regular direct measurements of AMOC strength started in 2004. To estimate the ocean current's health prior to this, scientists turned to a number of methods, including looking at paleoclimate records, running climate model hindcasts, and analyzing historical patterns in sea surface temperature. A paper published last year by Van Western and colleagues, which ranks second in Carbon Beef's roundup of most talked about climate papers of 2024, found that the present-day AMOC is on a trajectory towards tipping. That paper set out some of the climate impacts of such an event, including a 10 to 30 Celsius drop in average monthly winter temperatures in northern Europe within a century and a drastic change of rainfall patterns in the Amazon. So the question became, we wanted to address what would happen in a scenario where we have climate change and an AMOC collapse. Will it get cooler over Europe or will it get warmer? Will regional warming win or will the cooling win? Simulating AMOC collapse. To answer this question, the scientists run a raft of climate simulations exploring different combinations of global temperature rise and AMOC collapse. Specifically, the scientists explore the collapse of AMOC under 3 scenarios: an intermediate climate scenario, which is in line with current global climate policies, a very high emissions scenario where warming hits 4°C above the pre-industrial average by 2100, and a pre-industrial scenario without any human-caused global warming. Out of the freezer and into a frying pan. The most striking finding of the paper, according to Van Western, is that an AMOC collapse in a world that is 2°C warmer will result in a Europe that is cooler than it is today. Research notes that under the scenario, Northwest Europe is set to face profound cooling, characterized by more intense winter extremes. Summer temperatures, on the other hand, would be expected to remain just slightly cooler than they would in a pre-industrial climate, meaning that Europeans would experience dramatic swings in temperatures throughout the year. Increased winter storms and greater day-to-day temperature fluctuations are also expected in this scenario. This is due to a greater temperature contrast between Northern Europe and Southern Europe, which would be less impacted by weakened AMOC. The research notes that cooling from the reduced heat transfer from ocean currents will be amplified by extensive sea ice expansion to the coast of northwest Europe. Sea ice reflects incoming solar sunlight, resulting in less heat uptake and cooler temperatures overall. The map below shows the extent of sea ice in February under the scenario where AMOC collapses and the world is 2°C warmer. It shows how Arctic sea ice, when at its yearly maximum, would cover the coasts of Scandinavia and much of the island of Great Britain. Frigid cities. While the paper itself uses the Dutch town of De Bilt as a case study, the researchers have published projections for a range of European cities under the scenarios explored in the study. For example, the data shows that under AMOC collapse in a 2°C warmer world, London could experience an average winter temperature of 1.9 Celsius, roughly 17.6 freezing days each year, and 1 in 10-year cold extremes of minus 19.3 degrees Celsius. In the Norwegian capital of Oslo, average winter temperatures are projected to plunge to minus 16.5 Celsius, with maximum daily temperatures not surpassing 0°C for almost half the year, or 169 days. The research suggests the Norwegian city could experience cold extremes of minus 47.9 Celsius. The map shows projected cold extremes under 2°C of warming and AMOC collapse in cities in Belgium, France, Ireland, Netherlands, Switzerland, and the UK shows how temperatures could drop to minus 29.7 in Edinburgh and minus 19.3°C in London and minus 18°C in Paris. You can see here what the map would look like in this sort of scenario with plus 2 degrees C of global warming with a collapsed AMOC. As you can see, the temperatures move down from the North Pole quite dramatically into parts of North America, Europe, and also into Central and Eastern Asia. See the United States and the effect that would have on the United States. Here you have Europe and what would be a much colder Europe than what we currently have. And here we have Asia with extremely cold temperatures stretching as far south as the Himalayan mountain range. Given that observational data is limited, theoretical climate modeling approaches need to be taken properly to investigate this topic. Van Western and Bateson motivate the need for more detailed investigation into the combined impacts of global warming and AMOC decline on European extreme temperatures. Dr. Yukul Chin, researcher at Seoul National University's Climate System Lab, tells Carbon Brief, although this research demonstrates the potential for more extreme weather under combined global warming and AMOC collapse scenarios, significant uncertainties remain that must be resolved before we can qualify risks or devise robust mitigation strategies. Projections about AMOC have large spread, and it means that alternative AMOC trajectories and different levels of warming could substantially widen the range of possible outcomes. The comments are echoed by Ramstorff from Potsdam University, who points out that the exact outcome for Europe hinges on the development of two opposing trends: global warming due to greenhouse gases and regional cooling due to AMOC weakening, he says. The balance between those two will depend on the speed and extent of these trends and will therefore depend on the emission and AMOC weakening scenarios. Therefore, the more scenarios will be explored with different models in the future, we'll see a range of different outcomes for Europe as well as other parts of the world. A large uncertainty in this respect will remain. This is where D2 Incorporated can help. We recently just launched this new technology, our aluminum CTD profilers, which are going on to the Argo program, and we hope to help the industry better collect data on temperature, salinity, and pressure data, along with other elements of the ocean with our new equipment. With our closed-field, free-flowing cells, the first ever in the industry, we're able to provide salinity data all the way down to the bottom of the ocean and throughout these current systems so that scientists can better understand what is going on in the AMOC. Check out our brand new page regarding these CTD profilers that's available on our website. The next very interesting piece of technology we're going to cover in this episode of Ocean News is an octopus-like robot that swims with impressive speed and grace using just 2 motors. Researchers at the National University of Singapore have built a soft robot which hits speeds of 314 millimeters a second, matching more complex robots while being more energy efficient. Instead of controlling each arm separately, the robot uses an umbrella-style mechanism to move all 8 arms in sync. As it swims, the arms open to reduce drag, then snap shut to create thrust, just like a real octopus. This clever design can be used for underwater exploration, environmental monitoring, or even search and rescue. Nature-inspired robotics at its best. Another piece of very interesting marine science and oceanographic technology comes out of NATO Maritime Command. These 4 WAM V 22 Unmanned Surface Vehicles, USV, by Ocean Power Technologies, are putting their stability and versatility to the test in the Gulf of Finland. These trials are taking place during NATO's Dynamic Messenger small-scale event with assets assigned to Task Force X. The larger WAM/V 22 platform is designed for a range of missions from hydrographic surveys to maritime surveillance, demonstrating the growing role of autonomous systems in securing the seas. NATO is conducting a series of capability demonstrations of uncrewed vessels in the Baltic Sea throughout the month of June to advance the integration of these vessels into allied maritime operations. #WeAreNato. At Woods Hole Oceanographic Institute, we have a story regarding zooplankton, a crucial link in the marine food chain. By studying these tiny animals, scientists get a sense of the ecosystem's health, an especially important factor for commercial fishing regions like New England. So how do we know what's out there and how many? Assisted by AI, underwater imaging technologies identify and count zooplankton with remarkable speed and accuracy, giving scientists crucial insights into our changing ocean. Check out this small film that was done aboard the RV Neil Armstrong at the National Science Foundation, funded by Northeast Shelf Long-Term Ecological Research Station by Daniel Kojanu and Rachel Mann, and produced by Undercurrent Productions and Woods Hole Oceanographic Institute.
It's really fun to be out here in this day and age because we have so many cool technologies that we can bring to help us observe the challenging ocean ecosystems that are underwater and mostly microscopic. We're using a combination of things like high-speed underwater imaging and also acoustic sounding, as well as traditional methods like net tows to collect animals and bring them back on board the ship so we can study them in more detail.
We deploy this high-resolution imaging system called Stingray, and it captures really detailed images of the organisms and also captures the environment, so the basic parameters of where they're living. And so, for instance, just on this cruise, we've already seen a dense patch of sea butterflies or pteropods right near the surface. A lot of them are hanging out at deeper mesopelagic depths during the day and then migrating up to the surface at night. And I really find zooplankton to be this real middle box, right? So they're right smack in the middle between the primary producers, the phytoplankton, and then the forage fish and higher trophic levels. So they're this conduit between the surface layers and the deep ocean is really technologically challenging to sample, but so essential for understanding the system as a whole.
Yeah, exactly. And they're kind of in this. We're working intensively with things like machine learning and other kinds of artificial intelligence to help us make the most sense we can of these vast quantities of data we're now collecting.
I'm trying to create kind of a library of all these animals we're seeing, and so we can then use kind of sophisticated machine learning algorithms to automate some of our processing of that data. And the ultimate goal is really to define who's in the water column, where they are, and how abundant they are.
I have another clip for you from a dive in the SEAmagine 2-person submersible deep sea in the Maldives, operated by Dive Butler International at the Patina Resort. We spent the dive cruising along a reef wall, observing marine life as it approached us, and one nice moment was watching a large school of rays gliding past. These aren't deep technical dives, but they offer a great perspective on the underwater world and a safe, comfortable way to experience the ocean firsthand, and I found this to be quite interesting, so check it out.
Yeah, yeah, yeah.
Wow.
Whoa. Hey guys.
Next story comes out of Woods Hole Oceanographic Institution. It's not a whale watch, but more of a listen. WHOI recently joined forces with Massachusetts Division of Marine Fisheries to expand an underwater network that listens for marine mammals, including the critically endangered North Atlantic right whale. These new acoustic buoys alert mariners to whales off the coast of Massachusetts in near real time. Another extremely interesting new find in the ocean: 230 new giant viruses discovered that shape Earth's oceans. A giant virus infection of the unicellular algae Florenciella. The giant viruses can be seen bursting out of the Florenciella cell with their hexagon-shaped capsids that enclose their genetic material. Giant viruses play a role in the survival of single-celled marine organisms called protists. These include algae, amoeba, and flagellates that form the base of ocean food webs. And since these protists form an important part of the food chain, these large DNA viruses are often responsible for various public health hazards, including harmful algae blooms. A new study from the scientists at the Rosenthal School of Marine, Atmospheric, and Earth Science may help unravel the many types of viruses present in our waterways and oceans. This knowledge could help local leaders better prepare for when a harmful algae bloom may be impacting their coastline, or if any other viruses are present in local bays, rivers, or lakes. Using high-performance computing methods, researchers identified 230 novel giant viruses in publicly available marine metagenomic datasets and characterized their functions. Published in the journal Nature NPJ Viruses, their findings include the discovery of new giant virus genomes previously unknown in literature. Within these genomes, 530 new functional proteins were characterized, including 9 proteins involved in photosynthesis. This indicates that these viruses may be able to manipulate their host and the photosynthesis process during infection. A phylogenetic tree was constructed using the POIB marker gene from our recovered GVMAGs, as well as POIB genes from a curated set of reference genomes representing all major GV orders and families. The type of sequence as well as the location of recovery are represented as color strips on that tree. The tree was constructed using IQ-Tree with LG plus F plus R10 model and 1000 bootstraps. It was visualized using ITOL. By better understanding the diversity and role of giant viruses in the ocean and how they interact with algae and other ocean microbes, we can predict and possibly manage harmful algae blooms, which are human health hazards in Florida as well as all over the world, said Mohammed Madaruzzaman, co-author of the study and assistant professor in the Department of Marine and Biology and Ecology. Giant viruses are often the main cause of death for many phytoplankton, which serve as the base of food web, supporting ocean ecosystems and food sources. These novel functions found in giant viruses could have biotechnological potential, as some of these functions might represent novel enzymes. Until recently, giant viruses were largely undetected by scientific methods due to limitations in bioinformatic pipelines. These researchers created an innovative tool called BEREN, bioinformatic tool for eukaryotic virus recovery from environmental metagenomes, designed to identify giant virus genomes with extensive public DNA sequencing datasets. The authors used the University of Miami's Pegasus supercomputer at the Frost Institute for Data Science and Computing, IDSC, to process and assemble large metagenomes, often exceeding a gigabase per library, enabling the reconstruction of hundreds of microbial community libraries. The study allowed us to create a framework to improve existing tools for detecting novel viruses that could aid in our ability to monitor pollution and pathogens in our waterways, Minch added. The BEREN program used to facilitate this research fills a gap in the research field by providing an easy-to-use one-stop tool for identifying and classifying giant viruses and sequencing datasets. BEREN is available for anyone to use and can be downloaded at that link available on the screen. Our last story in this Ocean News episode comes from Antarctica. Strange radio pulses detected coming from the ice in Antarctica. Quote, the radio waves we detected were at really steep angles, like 30 degrees below the surface of the ice, said Stephanie Wissel, Associate Professor of Physics, Astronomy, and Astrophysics who worked on the ANITA team searching for signals from elusive particles called neutrinos. She explained by their calculations the anomalous signal had to pass through and interact with thousands of kilometers of rock before reaching the detector, which should have left the radio signal undetectable because it would have been absorbed into the rock. It's an interesting problem because we still don't actually have an explanation for what those anomalies are, but we do know is that they're most likely not representing neutrinos, Wissel said. We have these radio antennas on a balloon that flies 40 kilometers above the ice in Antarctica, Wissel said. We point our antennas down at the ice and look for neutrinos that interact in the ice, producing radio emissions that we can then sense on our detectors. These spatial icing interacting neutrinos called tau neutrinos produce a secondary particle called a tau lepton that is released out of the ice and decays. The physics term referring to how the particle loses energy as it travels over space and breaks down into its constituents. This produces emissions known as air showers. By analyzing data collected from multiple ANITA flights and compare it with mathematical models and extensive simulations of both regular cosmic rays and upward-going air showers, the researchers were able to filter out background noise and eliminate the possibility of other known particle-based signals. The researchers then cross-referenced signals from other independent detectors like the IceCube experiment and the Pierre Auger Observatory to see if data from upward-going air showers similar to those found by ANITA were captured by other experiments. Analysis revealed the other detectors did not register anything that could have explained what ANITA detected, which led researchers to describe the signal as anomalous, meaning that the particles causing the signal are not neutrinos, Wissel explained. Penn State has built detectors and analyzed neutrino signals for close to 10 years, Wissel explained, and added that her team is currently designing and building the next big detector. The new detector, called PUEO, will be larger and better at detecting neutrino signals, Wissel said, and will hopefully shed light on what exactly the anomalous signal is. Quote, my guess is that some interesting radio propagation effect occurs near ice and also near the horizon that I don't fully understand, but we certainly explored several of those, and we haven't been able to find any of those yet either, unquote, Wissel said. Quote, so right now, it's one of those long-standing mysteries, and I'm excited that when we fly PUEO, we'll have better sensitivity. In principle, we should pick up more anomalies, and maybe we'll actually understand what they are. We also might detect neutrinos, which would in some ways be a lot more exciting, unquote. Please make sure to subscribe and like and share this video and head over to d-2.com/news and bookmark our news page and check it regularly so you don't miss out on important updates like my recent interview with Marine Technology News. Thanks again for watching and hope you have a wonderful day.